We are starting with mensuration questions. And these mensuration questions, whether it's about 2D or 3D, it's related with symmetry. They are from the topical book. Let's do some paper one questions first. The seven-sided polygon in the diagram has 6 angles of x degrees each. 1, 2, 3, 4, 5, 6. And one of y degree. Now, let me just highlight these angles. So there is 1, 2, 3, 4, 5, and 6. And there is one angle of y degree. Now, the question is asking, draw the line of symmetry on the diagram. So the line of symmetry is actually this one. Why? Because now you can very clearly see these two will overlap. That means this side will overlap with this side. These two would overlap, these two would overlap, the half of y and the half of y would overlap. So that's the line of symmetry for 1 mark. If y is 126, calculate the value of x. So first of all, we will write y plus 6x should be equal to sum of polygon of a 7-sided figure. So polygon, the sum of interior angles, that is equals to n minus 2, which is 7 minus 2 into 180 degrees, which is 5 into 180 degrees. So this is 5 into 180 degrees. Y is 126. So 126 plus 6x equals to 5 into 180 is 900 degrees. Therefore, 6x is 900 minus 126. 900 minus 100, that's 800. 800 minus 20 is 780. 780 minus 6 is 774. Well, it's a paper one question, but if you are doing it right now and you want to double check, you can also double check using a calculator. So that's 900 into minus 126, that's 774. And when we divide it by 6, so x comes out to be 129 degrees. That's the value of x. So write your answer over here. That's 129 degrees. So this is all good, all clear. Another question, more or less along the same line. That is, in the diagram, the dashed line is the line of symmetry. So let me draw this thing. This is the line of symmetry. BAF is 2x. BAF is 2x. That is this one. That means this should also be 2x. And if this is x, this should also be x. And if it's 2x like this, therefore this should be 2x like this. So let me just focus on this. So this is 2x. That goes like this. This is x degrees. This is 2x degrees. That goes like this, 2x degrees. So therefore, how many are there? 2x plus x, 3x plus 2x, 5x. This is 10x degrees is equals to, how many sides does it have? 1, 2, 3, 4, 5, 6. 6 sides because 6 angles. So that is 6 minus 2 into 180 degrees. So therefore, this is 4 into 180 degrees. And that is 720 degrees is equals to 10x degrees. Therefore, x is 72 degrees. That's the answer for this part. Okay. Now, this question over here, I would like you to try it out. I'll pause the recording. So now let's look at this question. The diagram shows a figure made from 5 identical triangles. So these are 5 identical triangles. The figure has a rotational symmetry. Write down the order of rotational symmetry. That's very obvious. That's 5. Because the same figure is identical. So, and there are 5 of them. So this is 1, 2, 3, 4, 5. There will be 5 turns for it to reach from one place back to the original one. So that's the order 5. Each marked angle is 110 degrees. Find the angles of one of the triangles. Okay. Now, first of all, let me draw it a bit more. So this is one side. This is the other side like this. Not the whole side, just this much. And the third side I'm drawing in blue. And this angle I'm marking in red. So if this is 110 degrees, therefore this is 70 degrees. Angles on a straight line is 180 degree. And then if I talk about this angle, the blue, the green angle, let's say, this angle, this angle, this, and this. So this is 360 degrees divided by 5, that is 72 degrees. So therefore, this is 72 degrees. And now I'm left with this angle. Let me call this thing as theta. So theta plus 70 plus 72 equals to 180. Theta plus 142 degrees is 180. Therefore, theta is 38 degrees. So there is 38, there is 72, there is 70. There is 38, there is 72, there is 70. These are the answers, and that's the order of rotational symmetry. Now let's try some paper 2 questions. This is again a question just like before. So I don't think so I'm going to try this. I'll leave it for you to try it later. And mensuration with paper 1. Let me look at this question. This looks like a nice question. Again, I would like you people to try it out first. So now in this question, it says the diagram shows a shape made from thin wire. The shape is formed from 3 identical sectors of a circle. These are the 3 identical sectors of a circle, each with an angle of 40 degrees. And the angle between each pair of sector is x degrees. So there are these 3 angles which are the same, the 40, the 40, and the 40. And then there are these 3 angles, they are the same. So state the order of rotational symmetry. The order of rotational symmetry is 3. That's easy. Calculate the value of x. So there are 3 40s and there are 3 x, and they should equal 360 degrees. 40 plus x is 120 degrees. Therefore, x comes out to be 80 degrees. So that's the value of x. And the last part, in this part, take the value of pi to be 3 because it's a paper 1 question. Given that the total length of the wire is 60 centimeter, calculate the radius of one of the sectors. So now, first of all, this is R, this is R. There are how many R's? 6 R's. And this is S and S and S. So therefore, 6R plus 3S. This equals to 60. Now, separately, S is equals to theta over 360 degrees into 2 pi R. Now, theta is 40 degrees, 360 degrees as it is, pi is 3, and R is, what's the value of R? Calculate the radius. That is exactly what we are looking for. So we will write S in terms of R. So first of all, cancel the zeros. And 2 into 3, 6. So this 6 will go with this. So this comes out to be 2/3 R. S is 2/3 R. So 6R as it is, 3 times S is 2/3 R equals to 60. 6R plus 2R equals to 60. 8R is equals to 60. Therefore, R is 60 over 8. 2 into 4 into 15. 4 into 2. So therefore, R comes out to be 7.5. Calculate the radius. That is the answer. That is centimeters. So this is 7.5. This is 80. This is 3. This is all good. Now, this is another classic question. It says that the diagram shows the metal cover for a circular drain. Water drains out through the shaded region. So this 1, 2, 3, 4, 5, and 6. There are 6 pieces like this. Then there is, hold for a second, there is this 1, 2, 3, 4, 5, and 6. There are 6 pieces like this. So water drain out through these. O is the center of the circle with radii 1, 2, 3, 4, and 5. So there are 5 circles. So this is O, this is radius 1, and then radius 2, radius 3, radius 4, radius 5. The cover has a rotational symmetry of order 6, which makes sense. 1, 2, 3, 4, 5, 6. These green tick marks are also 6. The blank ones are also 6, and so on. This angle is 40 degrees. BOC is 40 degrees. That's this one. BOC. So this is, for a second, let me go back. So this is B till O, O till C. This angle is 40 degrees. Calculate the area of the shaded section ABCD. So area of the shaded section A, B, C, and D. Now, first of all, let me draw it like this. This is 1 like this, and then 1. This is 1 centimeter. I'm adding another centimeter, 2. Then the third one, this is 3rd centimeter. This is the 3rd one. And then the red one, this is the 4th one. This is the 4th one. So now if I talk about OBC, so let me first talk about OBC. So I have sector OBC. And then I'm talking about the sector OAD. So for OBC, this is 1, 2, 3, 4 centimeter. And for OAD, this is 1, 2, and 3 centimeter. So this radius is 4 centimeters. This radius is 3 centimeters. The angle is 40 degrees. The angle is 40 degrees. And then what are we looking for? We are looking for area of that segment. So area of the sector is 40 over 360 into 2 pi into R. R is 4. And over here, area of this sector is also 40 over 360 into 2 pi into 3. So what is the only difference? The only difference is that 4 and 3, everything else is the same. So therefore, area of ABCD, the shaded section, that is 40, 360, 2 pi. This is 4 minus 3, which is 1. And this is not 2 pi r, pi bad. It's the area. So let me just correct myself. This thing is pi r square. So this is pi, and this is 4 square. This is pi, and this is 3 square. So this is 4 square, this is 3 square. Mistakenly, I wrote the formula for arc length. So now it's pi over here. So first of all, let me just correct this. So therefore, there is a pi and something like this. So now, in terms of pi, so first of all, 41s are 49s are. And we are left with pi over 9. And this is 16 minus 9. 16 minus 9 is 7. So that is 7 pi over 9 centimeters square. That is the answer. 7 pi over 9. Let me check this first answer. So that is 7 pi over 9. Now let's move ahead. Now the question says, the total area of the metal unshaded section of the cover is 55 over 3 pi. The total area of the shaded section, give your answer in terms of pi. Now this is a tricky question. First of all, the very last circle, this one with radius 5 centimeter, I don't need this thing. That's the first thing. So basically, I'm interested in this thing. And if I find the area of the circle, and if I subtract the metallic part, which is the white part, therefore, I'll get everything that is the black part. Make sense? Listen to me again. The total area of metal, the unshaded, the white area, is this much. The total area of the shaded we are looking for. So area of circle is pi into 4 square, that is 16 pi. So 16 pi minus 55 over 3 pi. Take pi common. This is 16 into 3 minus 55. Hold for a second. Let me just look at this one thing. That is the area of the small circle. There is the big one. That's the second one. This is the third one. There is the fourth one. And oh, the metal is also there. My bad. This is also a metal. So this is not a white surface. This is 5 square. So I cannot ignore that. Hold for a second. So this is pi into 5 square. That is 25 pi. So now, yes, it cannot be ignored. So this is 25 pi. So 25 into 3 minus 55 divided by 3. So this is pi over 3 and this is 20. So 20 pi over 3, that's the answer. 3 into 6 is 18. 18 plus 2, that is 20 over 3 pi. So this is also good. So I thought that was a blank space. No, that blank space is what I'm looking for. That is the metal. So that needs to be subtracted. Now it says, calculate the fraction of the total area of the cover that is metal. Give your answer in the simplest form. So metal is unshaded. Metal is unshaded. That is 55 over 3 pi. So 55 over 3 pi divided by total area, that is 25 pi. So the pi will cancel out. 55 over 3 divided by 25. 55 over 3 into 1 over 25. That is 5 into 5, 5 into 11. That is 11 over 15. Is that the answer? Yes, the answer is 11 over 15. So this part is also done. Some more paper 2 questions, something like this. It says diagram 1 shows a design, and get your calculators ready. Diagram 1 shows a design which consists of 7 congruent circles drawn inside a large circle. So there are 7 congruent circles, and they are this one: 1, 2, 3, 4, 5, 6, 7. They all are congruent. The circles touch at all points shown. State the order of rotational symmetry. So basically, the order of rotational symmetry is like 1. This is like 1, 2, 3, 4, 5, 6. This middle one is like the excess in the middle. So order of rotational symmetry is 6. In the diagram, 2 sections of the designs have been shaded. Each small circle has a radius of 5. Calculate the area of the large circle. Now, first of all, if I talk about the small circle and it has a radius of 5, that means it's going like this, all the way like this. So this is 5 and 5. This is 10. This is 10. This is 10. So the diameter of the large circle is 30. Therefore, radius of the large circle is 15. That's the first thing. Area of the large circle, that is area. That is pi into 15 square, which is 225 pi. I'm leaving the answer in terms of pi unless otherwise needed. The shaded area. Area of the small circle, that is pi into 5 square. That is 25 pi. There are 7 such circles. 7 into 25 pi. That comes out to be 175 pi. Therefore, the difference is 225 pi minus 175 pi. That comes out to be 50 pi. But how many such areas will be here? 6. This is one area. This is the other one. Third, fourth, fifth, sixth. So therefore, the shaded area is 50 pi divided by 6, which can also be written as 25 pi over 3. Now let me check the answers still here. So part 1, 2a and 2b. So part 1, 2a, that is this, and this is the answer after multiplication using pi. And this is the other answer. Again, this is, if you use the calculator, you will get this value. And this thing is done. Yes, now this is one important thing that I want to emphasize. Work in terms of pi till the very end. Then use pi as 3.142 because it's a 4 significant figure value. So if you use the value at this point, that will be perfect. So you will be not messing up like the examiner is kind of messing up. So don't just get this final answer all the way at the end. Now let's look at part B. Now it's kind of trigonometry. It says in the diagram, the circles OAB are shown together with the same shaded area. O is also the center of the large circle. Write down angle AOB. That's very easy. Again, because of this rotational symmetry. So because of this rotational symmetry of order 6, this angle is 60 degrees. Why? Because this is 360 divided by 6, which is 60 degrees. Calculate the total perimeter of the shaded area. Now, how should we work it out? Now, first of all, we have A and B and all these things. So let me first focus on this. So if I focus on the small one, this is 5. Hold for a second. This is 5 and this is 5. And then this is 10 and then this is 10. So now, if I talk about this thing first, the purple one I've used, let me use the blue one. So let me use the blue one from here, like this. So if I focus on the sector, let me write this thing as C and D, OCD. Therefore, the radius is 5 plus 5 plus 5, which is 15. Angle is 60 degrees. And we are interested in the perimeter. Let's see. Yeah, that's the only thing. So perimeter is arc length CD. That is equals to, if I need CD, that equals to theta over 360 into 2 pi into r, which is 15. So first of all, 60 ones are, 66 are, 2 ones are, 2 threes are, and then 3 ones are, 3 fives are. So this comes out to be 5 pi. Leave it as it is. I'll use the calculator later. This is arc length CD. So this CD is found. Now, if I talk about the total perimeter, that should also include this thing. That is also part of the shaded region. That should also include this thing. So if I include this, let me call this thing as M, let me call this thing as N. So MC and NC is the same. So MC and NC, this is the same. That is the semicircle of which circle of small circle. That is semicircle small. Let me write it like this. So MC plus NC, that is circumference of the small circle because I'm adding it up. So therefore radius is 5. Therefore circumference is 2 pi r. That's 2 pi into 5, which comes out to be 10 pi. So now this is also found. This is MC and NC combined. So now this is 5 pi This is 10 pi. This is 10 pi. If I'm not mistaken, this is 2 pi r, 2 into pi into 5. That is 10. That is this and this combined. So basically, this is 5, this is 5, this is 5. So three things are found. Now let's find mn. So angle is the same, radius is 5. So I need one extra piece of paper. So now we have angle is 60 degrees. Radius is 5 centimeter. So this is arc length mn. That is 60 over 360 into 2 pi r. So 2 pi into 5. So again, 60 ones are, 66 are, 2 ones are, 2 threes are. This comes out to be 5 pi over 3. We have this thing, we have this thing, we have this thing. So therefore, the perimeter is 10 plus 5 plus 5 over 3. Everything has pi in it. I'm taking common out. This is 15. 15 into 3 is 45. 45 plus 5. Or let me write 5 over 3 as 2 whole 1/3 or 2/3. 2/3. So this is 2 2/3. 3 twos are, sorry, 1 2/3. My bad. So this is 1 2/3. 3 into 1 is 3. 3 plus 2 is this thing. That's perfect. So therefore, 10 plus 5 plus 1 2/3 pi. So this comes out to be 16 2/3 pi, which can also be written as 50 over 3 pi, and this is in centimeters. So both are optional. Both options are possible. So this is this much, and then you can use the calculator and you will get this answer. Okay, so that completes our concept of mensuration with symmetry, and that's all about symmetry. Take care.